Hari Kishan sir, shall we start?
Yes, sir. Yes, sir. You can start, sir.
So I hope my screen is visible.
Yes, sir. Screen is visible and voice is also audible. You can continue, sir.
Okay, thank you, Hari Kishan sir. So good afternoon, everyone. And in this lecture, we probably cover the two methods. One is supervised learning algorithm, that is K nearest neighbors, and in the first half, and the second half will probably cover one unsupervised method, that is K means clustering, and just correlate with the or one of the application, maybe in the wireless communication, wireless sensor network, or cognitive radio. Right. So before we start this session of supervised and unsupervised learning, I'll just discuss some couple of fundamental points, and then we'll proceed to the supervised and unsupervised learnings. So because nowadays everyone using these methods of supervised and unsupervised learning to predict something or to calculate something which is important, and their modeling is somewhat difficult to achieve the results. So the few fundamental things is I'll tell you, because you have the large data. As we talk about the wireless sensor network, the sensor number of sensor is very large. Maybe the order is start from 10⁻⁴. So the number of sensor is very large, and if you simulate any wireless model, or you channel modeling, or you want to calculate the noise, or you can calculate the self interference, these method or machine learning play the important roles. So or you can find out the spectrum, unutilized spectrum in cognitive radio, then too also you can use these methods. So because the number of sensors, or you can say the number of devices or number of users, is nowadays very, very large. So whatever the data created or provided by these number of users or sensors, it's also very large. So we are playing with big data or large amount of data. So my point is that whatever the data you are available in the form of maybe in the database, or maybe Excel format, MSX format, or CSV format, this is very large. So number one point is whatever the data is available, that is known as the data frame, or it is in the rectangular format. What do you mean by rectangular format? Means data is in the some kind of matrices, or you can say the rows and columns. Right. So number one, we have the data frame, because when we do the hands-on with the help of Python, we know these small things, so we can easily program it and achieve the result in very short span of time. So we have the data in the rectangular format, where it comprises of the columns and number of rows, where row is nothing but your records. You also said that the inputs, or you can say the records. The row is represented by records. So row may be a 10,000, maybe a 20,000, 50,000, all lakhs of data. So it is very voluminous. Whereas the column represent your features, right? So column represent the features, and row is the records, and the last column in some of the result may be the output, or you can say my target. Okay. So we have basically a rectangular frame where we have n number of records. Basis on some column means features, we have to identify it belongs to which class, or we have to predict the result like that. If the output class is available, that means of the existing data, that is known as the supervised. You can apply the supervised learning. If the output class is not available, then we'll go for unsupervised learning, right? So this is just a brief introduction, because when you have the number of records and their respective features, you also apply the statistic statistical techniques onto it. So very simple, you can calculate the mean of that particular column or what particular feature, what is the maximum range, minimum range, what is its deviation, and deviation square, you can calculate the variance as well. So a lot of information you can take out from these particular columns or number of records. So you can apply the many sophisticated statistical technique. You also go for mean, mode, median, the variety of statistical operation you can apply. You can use the 25th percentile, 50 percentile, 75 percentile, like that. You can calculate whenever it's required. You can calculate easily. So you have just first you have to form what number of features is available, what sort of number of records is available, whether its record is sufficient to apply my algorithm or not, and whether the minimum feature are suffices our problem, or we can find out the solution with less number of features or not. What are the features are independent, what are the features are dependent, like that. You have to first find out the basic structure of your data, then only you can easily apply the algorithms easily. So here we'll start with the supervised learning algorithm, right? So I'll take one or two example, very small examples, so you can easily apply from these program onto your big data as well. So that is not the issue to apply this, because the 4 or 5 lines code is easily available in this Python library, right? So k nearest neighbor, will probably cover the what is k nearest neighbors, what is the factor of k, how we can decide the value of k. We'll take one or two example and finally conclude this first part of k nearest neighbors. So there are different nomenclature is also available of KNN sometimes. So most commonly used name is k nearest neighbor. It is also used on memory-based reasoning, or example-based reasoning, or instant-based reasoning. Why? Because whenever the one new data point come into the picture, or whenever you add new data points in your data set, it recalculates the entire calculation with respect to that new data point. So time complexity will increase in this particular algorithm. That's why it is also known as the lazy learning algorithm. So these are the 5 or 6 different nomenclature, right? So k nearest neighbors, memory based, example based, instant based, and lazy learning. Now, what is k nearest neighbor? It is one of the simplest supervised machine learning algorithm. As I told you, if you have the certain features, let's say 3 features, and let's say 100 records, and the 4th column will give you the result of the existing 100 points. And whenever you add the new data point, you have to calculate it based on the existing outcome. So if you have 100 existing records of your data set, you can easily predict them. So that's why it is a supervised machine learning algorithm. I'll take one example, then it is clear. Okay. It is a classification algorithm. So basically, it is a k nearest neighbors store all available cases and classify new cases based on the similarity measures. So it is written that it store all available cases, and whenever the new point is come, based on the existing similarity measures, you can predict the new cases. So maybe it is a distance function, or you can use the Euclidean distance, you can use the Manhattan distance, or you can say, if you are using the Euclidean distance, that means it is the L2 norm. distance. If you are using the Manhattan distance, that means you are using the L1 norm distance. It is the top data mining algorithm used today. And as I told you, because new instant is come, you have to recalculate an entire thing. So it is non-parametric lazy learning algorithm or instant-based algorithm, right? So if you look at this problem, right, in figure A, we have the n number of total data points where we have to find out what is the class of this particular data point. What is the class of this particular data points? So we'll first calculate the distance for your neighbor nodes. So suppose in this case, if I select the k is equals to 7, match, find out the k nearest 7 data points. So suppose this is green point, and I'll assume that initially, suppose my k is 7. Okay, so I'll take the first distance from this red point, then second point, then third point, fourth point, fifth point, sixth point, and 7th point. So if you calculate the distance, and out of 7, 5 are belongs to red and 2 are belongs to blue. So once you calculate the distance for the nearest neighbors, here I assume that k is equals to 7. So I calculate the total 7 points, and then we'll go for the result table of all the points. So out of 7, the total 5 points belong to the red category, whereas 2 points belong to the blue category. So it's very simple. This green is also belongs to the majority of the point, that is red, right? So basically, so the distance may be equivalent distance may be a Manhattan distance, or any other cost function, right? Similarly, if I take the example of figure V, if you look at this, so here also, what is the value of k? Because the circle, whatever the data point come in this particular circuit, I'll assume that is my k. So in this case, we have 3 data points. One is A, and another 2 points are B category. So these 3 are within the distance, and when we compare the results, when we tabulate these 3 points, so 2 points belongs to the blue or the circle category, whereas 1 point is belongs to square category. So this green point is behave as B or blue circular one, like that. So like that, you can easily calculate the data point property of green data point class, which class it belongs to, like that. Okay, so I hope this is a very simple tool for data mining. No the complex calculations, but it requires time complexity. Why? Because if I introduce one data point here, so again I have to calculate the distance of my each nearest neighbors. So once I have to calculate the distance, then I have to arrange into the ascending orders, then do the voting. Once the majority data points will available, then only we can predict the results. So every time when you introduce a new data point, you have to recalculate the distance from existing data points, right? So it is simple, but it takes more time. So in the previous example, in the case 1, we consider that k is equals to 7, whereas in the second example, we consider that the k is equals to 3. So one of the data points, or one of the example, we take the value of k equals to 7, whereas the second we have to take the value of k equals to 3. So the similarity of both the cases is we had taken the k is odd value. Why odd? Because we have to perform a voting. So if we take the k is equals to even value, it would be very difficult to apply the voting process, because maybe the result may be same. So k factor of knn is a parameters which refers to the majority of voting process based on the cost function, based on the cost function. Or this cost function is only applicable for nearest neighbors, not for the entire data point. It is only for the nearest neighbors. So the K will give you the neighbor value, number of neighbors in your set, number one. Second is, as I told you, the cost function is nothing but it is a feature similarity. So as and when you increase the number of value of K, you will get the better accuracy because it is a parameter tuning. But make sure you have to choose one. There is a trade-off. If you entire data point you assume that the K, so it would be very difficult. It takes a lot of time, right? So you have to choose in such a way, so not the very high value or not very less value of to predict the data points. And as we know that we cannot take K is equals to 1, otherwise it influence with the only the nearest point, and all the nearest point one by one having the same type. So we cannot divide into the two parts. So we cannot take K is equals to 1. Can we take K is equals to 2? No. Why? Because it's an even number and we have to perform the voting. So we cannot take the odd values. So the minimum value of my case is K is equals to 3. K is equals to 3. Now, as I told you, you can take as many as large value of K, but make sure it is not greater than the data points. So, but if you take the large value of K, the class may be differ. So we usually, to avoid this confusion, we have thumb rule for this. Not exactly you can say this is based on the literature. The K is always use the odd value to avoid the confusion of voting rights. Okay, and what is the minimum value? It's 3. We have already discussed. Number 1, minimum value is 3. Number 2, it is odd value. Number 3 is maximum value of square root of your data point. So let's say, for example, I have the total 100 data points, right? The square root of 100 is 10. So my value is, we cannot, take the value even numbers. And we also prefer the odd value. So you can take either value of 9 or 11, but because in literature it mentioned that the maximum value of K is a square root or less than the square root value. So we prefer, if the data point is 100, we prefer K is equals to 9. Okay. So I hope this point is clear, maybe to how to choose the K factors. So K is basically, number 1 is square root of data points, and second is odd value, and third, the minimum value of K is 2, 3. Okay, now I'll proceed to the slide. When do we use the K nearest neighbors? So obviously it is an algorithm of supervised learning. So that means the data is labeled, number 1. Second is data is noise free. What do you mean by data is noise free? That means initially I told you our data is in the rectangular frame and we have the columns of features value. If in the one of the record, if the one of the feature is missing, so we can delete that record for calculation purpose. That means now our data is noise free. So whatever the column or row is, whatever the row contain the non-labeled value or not available that particular feature of record, we remove that. Third is data is small. Why data is small? I'm not tell you the data is small means 10, 20, 30. Small means 10,000, 20,000. So not because it take the large computational time. So we prefer, if the data is small, we can easily apply the KN. So that's why, because this method is very easy. So most of the data mining algorithm, we prefer the K nearest neighbor algorithm. So now here I'll take the one small example. Now this is my rectangular frame. We have only 5 records, right? How many records? 5 records. Anna, John, George, Kevin, and Tom. These are my 5 records. So these are my records. Record 1, record 2, record 3, record 4, record 5. These are my features. What are my features? Age, income, and number of credits. These are my 3 features. This is what? Class, this is my outcome. This is my target. This is my outcome. Okay. So this is my output, my target, my outcome of my data set. So if you have these records, and because data is labeled, because the class is no or no, yes, no, no, yes, the class, what data is, very well labeled, noise free. Now I have to predict Tapan belongs to which class. If the Tapan's age is 37 and his income is 50K and having the number of credit card 2, whether it belongs to the yes class or no class. So how do we calculate it? So now, as you know that the square root of number of records, so square root is what? Square root of 5 is 2 point something. But the minimum value of K is what? The minimum value of K is 3. But the minimum value of K is what? 3. So in this case, if the minimum number of value is 3, then we will start the process and calculate the cost function. So just look at this example. Look at this example and just one time. So how many features you have? 3. Right? Age, income, number of credits. Right? So first here I prefer the cost function as my equilibrium distance. So the formula for equilibrium distance, you very well aware that xi minus xj square plus yi minus yj square plus zi minus zj square. It depends how many features you incorporated. So xi to xn, whatever the features. So here we have 3 features. So now I calculate the distance from Tapan to NA. Tapan to NA, how do we calculate the square root of 35 minus 37 square plus 35 minus 50 square plus 3 minus 2 square. And we calculate the distance from NA to Tapan as how much? It is 15.16. Right? Similarly, you can also calculate the distance from other. You also calculate the distance from the Tapan to John, 27 minus 37, 50 minus 50, 2 minus 2. So here this distance is 50. Then Tapan to George, 152.23. Tapan to Kevin, it is 122. Tapan to Tom, the distance is 15.74. So we calculate all the distances on classes. If you introduce new data point, again, you have to recalculate the distance from all the customers, right? All the customers. Once you calculate this distance, now we have to perform the voting rights. What is the value of K? K is now 3. So we have to select the 3 minimum distance customer from the data point Tapan. So we have 3 customer data point, that is NA, that is 15.16, John, that is 15, Tom, that is 15.74. So now we have the 3 data point distances from minimum distances of NA, John, and Tom. What is their class? Because now you have successfully identified the nearest neighbors from Tapan. Now, which class they belongs to? They belongs to NA belongs to no, John belongs to yes, Tom belongs to yes. So what is the result of Tapan? What is the result of Tapan? The majority. Majority is what? John and Tom is a majority of class yes. So Tapan is also belongs to class yes. So this is the answer. I hope this is clear to all. You can extend from any number of rows and columns, right? This is a very simple algorithm. So this is number one, basis on the record, we calculate the K. So here only 5 records. So we calculate the K is 3 because the minimum value of K is 3, number one. Here I have used the cost function as an equilibrium distance. That formula is, written in the bottom of the slide. So we prefer the equilibrium distance, number 2. Number 3, we calculate the equivalent distance from Tapan from each of the existing data point from 1 to 5, NA to Tom. Then once we calculate the distance or cost function, we identify or we successfully identify the nearest neighbors. So nearest neighbor of Tapan is NA, John, and Tom. NA, John, and Tom. And then we'll go for the outcome of these 3. Outcome of these 3 have no, yes, yes. So when we do the voting right of these 3 of nearest neighbors, that 1 belongs to no class, whereas 2 belongs to yes class. So majority is yes. So Tapan belongs to the yes class. Like that, you can easily calculate the value. I hope this example is clear. Now we'll take the second example again. Okay. So these are the features. This is the record 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 records. I have 11 records. So each customer having the age and the respective loan amount that is borrowed from the bank. So we have 2 features. One is age, one is loan. Whether the customer is defaulter or yes or no, that is the outcome is also already given. That means my data is labeled. That is my data is labeled. Okay. I hope this question is clear. So we have to identify whether the customer age is 48 and having the loan amount is $1,42,000, whether it is a default customer, yes or no. We have to find out. So now the same process. First we identify the number K. So the root of 11 is K, this 3 point something. So we'll again take that value is K is equals to 3. Right? So we again take the K is equals to 3. Okay. So here the K is equals to 3. Now we'll take the distance function. So 48 minus 25, 48 minus 25 plus 142,000 minus 40,000 square, and then we'll take the square root. The distance is almost equal to 102,000 dollar or whatever. Okay, so this is the distance functions. So one by one we calculate the distance function for 25, then 48 minus 35, 142 minus 60, 82,000, and like that we calculate the overall distance. Now, once you calculate successfully the cost function, we have to identify the nearest neighbors. So nearest neighbor of these 3 values of 3 distance says as one is this 35, is 35 and loan amount 120. Second one is age 60 and loan amount is 1 lakh. Third one is age 33 and loan amount is 150. Right? So if you identify successfully these 3 nearest neighbors, now we perform the voting. So when we perform the voting, the first is no class, second one is yes class, third one is the yes class. So finally, this answer is this customer is default yes. This customer is default yes. But the problem is, at the same time, the problem of this particular question is, if you look at carefully of loan amount, so what is the mean? 142 minus 40, that is 102. 140 minus 60, that is 82. 140 minus 80, that is 62. So this entire calculation is depend upon only on the one feature, irrespective of my age. Now that is the problem. Okay, so I think it understood that problem. What is the problem? In my record set, there are two features. One is age, another one is loan. And when we apply the KNN, the KNN only depend upon the one feature, irrespective of whatever your age. That is the problem. So how do we solve or resolve this problem that my algorithm work efficiently and it also bases on both the features. It depends upon both the features, age as well as loan. So we have to normalize this parameter. Every row you have to normalize. Normalize means basically we have to come into the range between 0 to 1 every. So the simplest way of normalization is just divide it into the maximum value and you will get the exact value. But the problem is, again, the range is very high. So to resolve this issue, to vary from minimum 0 to 1, we have used this particular formula for normalization. That means the current value minus entire value of that particular column divided by the range. Range means maximum value of that column minus minimum value of that column. Okay, so for an example, if you want to calculate the normalized value of 25, what is that? What is the minimum value of entire column? This is a blue one, 20. What is the maximum value of entire column? It's 60. So what is the range? 40. What is the range? 40. Now you substitute this value I, 25. 25 minus 20 divided by 40, 5 by 40, 1 by 8, that come out to be 0.125. Okay, so like that we calculate the value. Okay, let's say for example in loan part we have to calculate the first value. What is that? 40,000 minus what is the minimum value? 20,000. So 40 divided by 20, that come out to be 20 divided by 220 minus 20, 200. So 1 by 10 or approximately 0.11 or 0.1, like that. So you can just calculate these values. Initially, one value is in 0 where the minimum value is belongs to. So instead of 0, I'll just take some value. It is 0.01. Okay. So not set both the value 0, otherwise it discard that particular data because its data is noisy. It assumes that data is noisy. So avoid that. To without discard this particular value, I set that value is 0.01, like that. And once we have to normalized value, again we apply the same technique. 0.125 minus 0.7 square plus 0.11 minus 0.61 square, and then calculate the distance. Once I calculate the distance, in this case, what is the next step? We have to perform a voting. We have to perform a voting rights, right? So voting right means, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The same number of, the data points. So the square root of 11, again 3 point something. We consider that the k is equals to 3. And once we calculate the minimum neighbors value, what is the corresponding result of these 3 neighbors? So for 0.3160, the result is no. 0.3428 is result is no. 0.3650 is the result yes. So majority of the data is no. So now answer is no. But in my previous case, if you look at it, answer is no, yes, that is belongs to yes category. But this yes category is only dependent on one particular feature, that is loan amount, irrespective of age. When we consider both the parameters, age as well as loan, now my new answer, the customer that belongs to the age of 48 and loan amount is 142 lakh dollar is belongs to the default category no, right? So this is the some additional calculations when your total number of features is not successfully incorporated in your algorithm, in your labeled algorithm. So I hope this question is clear to all, right? So if you have any question, doubt, you can just ask and related to this numerical. Okay, so the as I told you, this is my last slide and conclude this topic of supervised learning. So the strength of KNN, I can say that the strength of KNN is very simple, very simple. And selection of K is also depend upon the number of entries. So square root of data point you can easily calculate. So it is very simple and intuitive method of K nearest neighbor method. It can be applied of any sort of distributions, whether the distribution is normal or Gaussian or whatever. You can apply easily. It is a good data mining, or you can say classifications, if the number of sample is large enough. But the same time, if the number of samples is large enough, as I told you, it is a lazy method. So that is its one of the weakness as well. Good classification when the number of sample is high, but at the same time, it gives you the time complexity. Takes more time to classify new example, already mentioned. Choosing K is very tricky. Number two, to also, you can just go through the features and whether the all the features are successfully, incorporated or not, to need to calculate and compare the distance for new examples or new data point entry. Need large number of samples for accuracy. Okay, so you have a trade-off. If it's not the large number of samples, you cannot apply. If you have large number of samples for accuracy, it will give you the good classifications. So that is this from my supervised learning point of view. If you have any question, related to this particular problem, so otherwise we'll take only 2-minute break and start with unsupervised learning. That means K means clustering. So dear participants, if you have any question, you can feel free to ask. So I'll take a 2-minute break, short break, and then we'll come up with the K means clustering. So welcome back. I hope my slide is visible to all. And
Yes, sir, it's visible.
thank you, sir. So if you have any question, you can meanwhile interrupt me. Now let's start the second part of my presentation, that is the unsupervised learning. So what is the mechanism behind it? We'll just go through it. Why it is known as the unsupervised learning, and what is the methods to be covered. So if you look at this particular block diagram, it is also a machine learning technique where you do not need to supervise the model, or you can say my data is unlabeled. So unlabeled means we have the n number of data points or raw inputs, but we don't know initially what is my class, whether it is divided into 2 parts, 3 parts, 5 parts, I don't know. So my data is not labeled based on their, the knowledge sharing capability of data point, or exchange the, the information, then only we can predict it. So it is one of the super machine learning technique, and allow to model to work on its own discover information. Own discover information means when they have the input raw data, they exchange the certain point, and they, based on their interpretations, they will form, or they conclude one kind of information. So in block diagram, if you look at the initially, this is the input raw data, and we don't know the how many class in the output. So unknown out, no training data set. Basis on their interpretations, or basis on their cost functions, they can discover some kind of information. And when they discover the information, we apply some algorithm like C means clustering. And once you apply the algorithm, the fourth block, when we process it, that time this data is labeled. So initially data is unlabeled. When we apply the algorithm, now the what data is labeled, and then we can easily segregate our input data. So here we don't know the number of output, but if you look at the output is divided into 3 parts: orange, green, and purple, or violet. 3 parts easily, right? But initially we don't know the class because our data is unlabeled. It is not labeled data. So most of the algorithm is unsupervised learning, like the neural network kind of thing. These are the unsupervised learning algorithms. Okay. So unsupervised learning basically divide the data into different parts. That is known as the clustering. So automatically split of the data bit into their subgroup based on their similarities or their own discover information. You can also identify the anomaly detection. If your unusual data point come into the data set, you can easily segregate, because that unusual data point is not shared the information to any other data points, not discovered the information of the nearest nodes as well. So you can easily find out the fraudulent transactions. Make it a subgroup, and that subgroup you can easily access to the entire data set. So the association mining is you can easily do. So identify the sets of items, and you can just easily classify into the database. So one is the big part automatically split. If you have the same part, you can do the pattern matching or associated mining. You can easily detect the anomaly detection or fraud transactions. You can easily identify basis on unsupervised learning. So here this is clustering. So if you look at the figure here, the homogeneous kind of information, and based on when you apply this exploratory data analysis, means based on the mean variance or based on the statistical tools, they have the intuitions, and after the process, you can easily, identify this particular data set is, belongs to 5 groups: green, orange, red, violet, or blue one. Like, you can easily, segregate the data. Now, how do we segregate the data? This is on which kind of similarity. So you can apply any of the similarity algorithms, like the correlation based, or the Euclidean distance based, or Manhattan distance based. You can apply any of the, cost function. So whenever these similarities matches high, they can form one kind of cluster. So what kind of similarity measures you have to use is just totally depend upon your application point. What sort of data, what sort of application. So you either go for the Euclidean direct calculation, or you can go for the correlation based clustering, right? And make sure these are the homogeneous. Homogeneous means they are belongs to the same category, same subgroup, not the heterogeneous environment. So right. So basis on if you have the 3 different kind of thing, so they can just combine only one kind of thing, one type of subgroup they can form. So basically it is not from the heterogeneous, it is from the homogeneous subgroup. Same kind of natures data you can easily extract it with the help of C-means clustering or clustering. Okay, so now in this figure 1, originally unclustered data basis on their similarity, now they form the clusters in 3 part, the green, blue, and red one, right? So unclustered data, and this is the clustered data. Right, there are a lot of clustering algorithm is available, and it is a very sophisticated, and now still the people are using it. Is also very old, but still people are using the same algorithm. So there are k-means clustering, mean shift clustering, kernel k-means clustering, k-medioids clustering. So they are the variation of the k-means is also available, but in this presentations we'll just focus on k-means clustering. So one very famous paper written by the highest cited Indians, Professor A.K. Jain from Michigan University, and he write one paper in 2010. So 10 years back, he write the paper, data clustering 50 years beyond the k-means. 50 years beyond the k-means. Now you can realize it's the most powerful clustering mechanism. It's proposed, the people are working in last 60 years, still people are working on this. So this is in the slide, Professor Jain, and in the center, and one of my good friend, Professor Nanda from IIIT Nagpur, and this is me. So during this conference, pattern recognition and image process, I interact with Professor Jain. He's a very nice and humble man, and still they are working on the different clustering mechanism. So very good paper. I also already cited in my presentation, and so when I share this, please go through this paper. You will take definitely some advantages of that. Professor Nanda is also working on the clustering, and they are write very good paper, this review paper, which incorporate around 350 journals, and that paper, review paper, nature inspired clustering. So that is also, you go through it. I also incorporate that paper in the end of my. So still people are 60-year-old technique, and still people are working on k-means clustering. So now you can realize that is the most powerful and supervised learning algorithm of machine learning. Okay, so basically, what is the steps? Basically, the k-means is the iterative algorithm. So we have to initially assume that we divide our entire data. It is simply an assumption, right? So we have to predefine the value of k. So suppose initially we define k equals to 2. So one of the data points belongs to either the cluster 1 or cluster 2. There is no overlapping of subgroup or cluster of any of the data points. if q belongs to the, if you define the k equals to 3, so that particular data point is only belongs to the one subgroup. At a time, it is not belongs to any other group simultaneously. So this is the basic number one assumptions or condition. Each data point belongs to only the one group. And it try to make the intercluster data point as similar as possible, while also keeping as cluster difference as far as possible. Means if you assume that the one of the cluster centroid, then the each of these data point for that particular centroid is distance is minimum, and same time to other cluster it is a maximum. Like that, you have to divide, you have to reiterative the process every time. You have to change the centroid so that the other data point distance is minimum at that particular subgroup. Okay, so for example, if you belongs to the top left, you assume this one subgroup. So you have to identify one particular data point where the all the subgroup data points have the minimum distance. It is not possible to far end you can select one point and every other data point distance is so large. So that is not the way. You have to select one particular data point in such a way the rest of the data point value of that particular cluster is minimum, right? So this is the objective function. This is the weight. Weight means either it belongs to the that particular data point is belongs to particular cluster or not. So that value is 1 or 0. If belongs to one point, it is 1. It does not belong, it is 0. So we have to minimize basically this distance functions. So this is the centroid coordinate, and this is the data point coordinate. So the distance will be minimum. So xi minus xk square plus yi minus yk square, and you have to click equivariant distance. So this double sign is norm to distance, denote the L2 distance, L2 norm distance. So we have to minimize this particular functions. So where this distance is very less of one particular data point. So this is the objective of this particular function, right? So procedure, as I told you, you have to specify the number of cluster. First, you initialize any of the centroid point, then calculate the distance, change the centroid point, and you have to iterate this process once the distance is minimum, right? So this is the step. We'll take this exam. This is the step, execution step, and this, right? So my point is, suppose you have this is unclustered data, right? You assume two centroid, one. So that means k is equals to, in this case, is 2. So you have assumed one blue or one red. So you calculate the equivalent distance from each of the data point to blue centroid as well as the red centroid. Whatever the distance is minimum, you assign 1 and rest of 0. So for this particular green point, it is near to blue one, so that is in blue color, whereas other one, which is the distance is large, it denote to red color, like that. So we have now, after first iteration, when we assume two centroid, after first iteration, you will see that the pink line is there. So some of the data point belongs to blue cluster and some of the data point is to red cluster. Now you have to dense area, you have to assume another data point, centroid. Now this centroid value is changed because you have to calculate the in such a way that distance is minimum. Once I move this, then you can look at it. Now we assumed in the figure C two new centroid. Instead of these old one, we assume that the two centroid. Again, apply the same technique. Now you look the pink line, the red one and the blue one. Again, in fourth one, you shift this some dense area. This centroid is select to some dense area. This centroid is some upward direction in dense area, and then like that you have to do the process. So now you can look at in figure E. Now you can see that my data point is accurately classified where the each of the data point distance is minimum as compared to the case 1. right? In figure A, this is the data point distance is very large, but nowadays in this case, the whatever the belongingness of particular cluster, the distance is very less, like that. So this is the example of k-means clustering, and how numerically we can solve it, I can tell you again this. Further noting once this approaches to 0 or minimum, right? So this is my example number 1. Now I'll take the, if you have any doubt, you can ask them. So number 1 is, first step is you have to assume that the value of k. So now I assume that here the k is equals to 2. This is my data points. Now I have to form two clusters because we assume that k is equals to 2, the blue one and the red one. So now this entire data set divided into two portions. So initially we can assume the equilibrium distance. So each data point we calculate the distance from blue and distance from red. If the distance is blue is minimum, assign 1. If is maximum, assign 0. So this pink line divided further into the two parts. Whatever the distance is minimum from blue, it is in blue color. Whatever the distance is, less from red, it is in red color. So this is the one test. Now we move to the randomly one of the data is chooses as the blue one. So we can just move this centroid value. So now this centroid is here and here. So initially we arbitrarily select this. Now one of the data point we can select this value. Again the same process. We have to calculate the distance from blue and red and further divide it into this. So whatever the distance is minimum from centroid, that is in blue color, otherwise in red color. Again this blue one is shifted towards down and red one is towards up, and going again further classify in figure E. So now in figure E, you have now a picture like this. And now you can calculate this distance, and now we can realize that there is no bifurcation nowadays, no changes of the data points. Half of the data points belongs to the red, and the lower one is belongs to the blue one. So no iteration is possible because now the cost function value is our objective function is approaches to 0. So we cannot change the position of my centroid in this particular example, like that. Okay, so now we'll take some numerical example 1. So how many data points? If you have 12 data points, how many features? I have 2 features. One is weight, one is height. Now we divide it into the clusters. How do we do that? Initially, we assume that the 2 clusters are K1 and K2 basis on 2 initial points. So initially, the first 2 points is assume that these are my 2 cluster, or you can say these are my 2 data points. Okay, so this 1 is belongs to cluster 1 and 2 is belongs to cluster 2, right? These are what? These are my centroid of my cluster 1. So what are the centroid of cluster 1 is 72 and 185 is my centroid. Similarly, the centroid of my second one is 56 and 170. So this is the. Now, if we take the third centroid, a third data point, that is what is the value is 60, 168. So if we calculate the objective function with the help of equilibrium distance, what is the value? So 72 minus 60 square plus 185 minus 160 square. So 72 minus 60, that come out to be 12 square, that means 144, plus 185 minus 168, that to be 17, that means 289 plus 144. So when you calculate this value of square root of 144 plus 289 is somewhere around 20.8. So this is my distance from 1 to 3. Similarly, you can calculate the distance from 2 to 3. 56 minus 60, that means 4 square means 16, plus 170 minus 168 means 2 square means 4. So 16 plus 4, that means 20. The square root of 20 is somewhere around 4.5. Right? So we successfully initially, what is the step? Initially, we assume that we have two clusters and their respective centroid is 72, 185, 56, 170. When the third data point, the new data point is come, we have to check the belongingness, whether this belongs to 1 or belongs to 2. So we calculate the cost function, that is mean distance function. So we successfully calculate the distance from 1 to 3, that is come out to 20.8, and we distance point 2 to 3, that come out to be 4 or 5. So now you look at it. We have two data points and we calculate the distance from 60 to 168. The distance from 1 to 3 is 20.8, 2 to 3 is 4.8. So what is the minimum of both the things? So of course the distance from 2 to 3 is minimum, that is only 4.5. So that particular 3 point is belongs to cluster 2. Why? Because this distance is minimum. Compare both the distance. One is 20.8, another one is 4.5. Which distance is minimum? Of course, it belongs to 2 to 3 distance is minimum. So 3 belongs to 2. So we can combine these 2 points. When we combine 2 and 3, what is the new centroid value? So the new centroid value is nothing but average of this. So 56 plus 60. What is the 56 plus 60 by 2? That is 58. 168 plus 170, that is 169. So the data point 3 belongs to cluster 2, and that their modified centroid is nothing but 58 and 169. So the 1 point is reduced. Now to the total data point is 11 instead of 12, because 3 belongs to the same cluster number 2. Now this process is repeated for fourth. What does it send? The value, the fourth point is value is 68 and 179. So 72 minus 68, 4 square, plus 185 plus 179. So 6 square. So 36 plus 16. 36 plus 16, that come out to be 52. That is 1/4 distance is 7.21. Right? And when we calculate the distance 4 to 2, 3 is 58 minus 68, that means 10. 10 square is 100. 169 minus 179, 10 square, again 100. 100 plus 100 is 200. And then the square root of 200 is 2 into root 10 into root 2. That is 10 into root 2 means 14.14. So of course, if you consider this, you compare the cost point data point 4 to 1 and 4 to 2, of course the distance is 7.21 is minimum. 7.21 is minimum nowadays. So the fourth point data point is belongs to cluster 1. So what is the new centroid value? So because the distance is 1 to 4 is minimum, so for data point 4 is belongs to the cluster 1. So now the value of this particular new centroid is 72 plus 68 by 2, 72 plus 68 by 2, that is 70. 185 plus 179, that is come out to 182. Like that, you can repeat this process. Now you can easily tell in my chat box whether the data point 5 belongs to which of the cluster, 1 or 2. Can you calculate the data point 5 belongs to which cluster? So if you calculate from 1, so 70 minus 72, that is come out to be 4. 70 minus 72 is 2. 2 square is 4. Plus 182 minus 182 is 0. So 4 plus 0, square root of 4 is 2. So 1 to 5 distance is 2. Whereas 2 to 5 is 58 minus 72. That is 14 square plus 169 minus 182, 13 square. So that is very large value as compared to the 2. So obviously the data point 5 belongs to cluster 1. And keep on, you can repeat this question and you can identify the values. So I hope this question is clear to all. If you have any difficulty, you can just unmute your mic, or you can just put it into the chat box. Okay, so Mohammed Ahmed sir asked one question. I'm sorry I missed this question. What is anomaly in unsupervised learning? Okay, sir, the anomaly detection, or you can say suppose you have the 100 data points. You have 100 data points, right? And suppose the new data point come into the picture. Suppose the new data point is pictures. So what basically do, whenever the new data point is come, you have to recalculate the distance from each of the clusters head or new centroid. When this value is very large, right? So you can easily find out why this value is very large. There is something is wrong or missing for one particular data point. So you can easily find out that fraudulent transactions or unusual behavior of your data point. So for whenever the unusual behavior, your instant changes of your data point, you can easily find out in that particular cost function, right? So this is the approach to find out the banking transactions in this case. So the unsupervised k-means clustering is also useful to the threat detections or anomaly detections. So does it the answer, sir? If you have any question, you can feel free to ask. Okay, so here the data point 5 is belongs to data point 1, and further you can repeat this step, entire steps, and you can easily segregate the data points. The next or last example, you can say that the in image segmentation. So if you have this colored image, this is my original image, just carefully. So in original image, we have the 8-bit image, we have 256 labels. So if you identify one intensity is belongs to one cluster, like that, you have to divide my images 26 categories. If you take only two labels, whether it is belongs to greater than 128 or less than 128. So the cluster value is only 2. So my pixel intensity is basically greater than 128 or less than 120. So in first image, I consider as I took that only the two segmentation or two clusters. So k equals to 2. If you take the k equals to 2 and compare the size of the original image to the k equals to 2, where the k is 256 and here the k is equals to 2, although image is not clear, but if you compare this, it required only the 4% storage as compared to the original image. So initially, if your original image is 100 MB, and if you apply the k equals to 2 clustering technique, then it is only the 4 MB in size. 4% of size. So you can say that you can do the segmentation also, and you can also compression also in the image. When I increase the number of k is equals to 3, just increase 1, the image is much clearer than the previous one. And then we'll go for k equals to 10, and then you can identify the resolution, or you can say the clarity will increase. But the same kind of time, the size is also increased. So you have the trade-off between the 256 and k equals to 10. You can find out at one particular value where the images or resolution is also good, and not required the number of labels of as large as 256. So there are a variety of applications. You can apply the same k-means clustering in your image processing as well, right? Now, this is the next point is what are the limitations? So here we have one data point set, and because we have to predict or initialize the k value, so I initialize k is equals to 2. So if I initialize k equal to 2, would be better if you have only take one cluster in this particular say. But we have to assume that the initial k value, so that is will give you wrong answer. And similarly, in the figure 2, if I take the 2 clusters, so we can easily segregate in here, easily segregate in this particular direction. Where that the cluster is come, you can easily segregate. But here I assume that 1. So these are the some, one limitation to, choose the value of k. Another limitation, if you look these two images, so from here point of view, these are the much similar images. But these two images are entirely different. But due to the similarity object, it will give you the nice result, right? Those two samples might be very close in features, one particular space, but actually they are very, very much different. So these are some limitations. Now, if you talk about this, circular shape or elliptical shape kind of thing, here they easily, segregate the two clusters, the blue and red one. But you apply, once you apply the k-means clustering, then the sum of the blue point belongs to the red one, and sum of the red point belongs to the blue one. So that is give you the bad, clustering result in the round shape kind of thing. So first you have to, take the do the research on your data part, and then only you can apply the k-means clustering, right? So this is the end of my presentation, and so these are my references beyond k-means by Professor Jain and one nature-inspired partitioning algorithm. If you have any questions, just you can feel free ask to me, because I know it is very difficult after the attend the session after the lunch.
Yeah,
difficult.
Sir, thank you very much, sir. It's a very informative session. Suddenly you planned and informed exactly with things required. So I appreciate you, sir. And you and madam has taken lots of pain today to conduct the session. Thank you, sir.
Thank you, Harikesan sir, to give the opportunity to interact with the participants.
Yes. So, okay, if participant wants to interact with the sir, you can.
If you have any question, you can feel free ask, or you just noted down my email ID. You can just drop an email to tapankumarjain@gmail.com. Any question from participant side?
Okay, sir. Then we'll end the session. Thank you, sir. Thank you for the informative session. Thank you once again.
Okay. Good day, sir. Thank you. Bye-bye.
Yeah, sir. I'm leaving. Okay.